Okay, so continuing with section, question number 7. So given the polynomial and we are given a factor of the polynomial. So the question is asking us to find and list all the zeros. All the zeros of what? The zeros of p of x, the given polynomial. So what we are doing here is actually the continuation of the previous. This is kind of a continuation of the previous problem in which we were asked to find the all rational zeros and then find one of the zeros. So list down all possible rational zeros and then we had to find 1 0. So we found 1 0. I think it was -1 was the 0. So what we would have done to find the rest of the zeros was to divide the given polynomial by that factor that we found, x plus 1, and then go from there. So but it becomes a very long question, so usually in the exams we don't give ask for that long part. We divide it into 2 pieces. So one half you find and list the possible zeros and then find at least 1 0, and in another portion we are doing the other part, which is division of the polynomial and finding the rest of the zeros. So in this case we will divide the polynomial by the factor x square minus x plus 1. So here is what I did, the division. So once we divide it, we are seeing that we are getting 0 as the remainder, which means this given factor is a divisor of the polynomial, or is a factor of the polynomial, so that p of x can now be written as quotient multiplied by the divisor. So x square minus 2, which was the quotient up there, times the divisor. Now we have to find all the zeros, remember. So we set it equal to 0, which means each factor is set to 0, and then we solve. So this one, I'm solving it over here. X square minus 2 is equal to 0. So we can write x square is equal to 2, or x is equal to plus minus square root of 2. So we got, remember, it's a degree 4 polynomial. So there should be 4 zeros. So 2 of them we found. Now the 2 we will find by solving the other equation, and we notice that this is not factorable, cannot factor, so use the quadratic formula. Make sure that you know the quadratic formula exactly. So here is the formula: negative b plus minus square root of b square minus 4ac whole divided by 2a. So our a is, it's always a good idea to list it down. A is 1, b is -1, and c is 1. So plugging in the formula, here I did that. Simplifying, we see that we get a complex number. Square root of -3 can be written as square root of 3i. I is outside the root. So sometimes you can write it plus minus I square root of 3 over 2. But since we have to write our complex in that form, a plus bi, so we split it. We write it half plus square root of 3 over 2i. Now I, if you feel like you might put it under the square root, then put it front instead. But then here are all the 4 zeros that we found. Okay, looking at the next one, well, next is actually the opposite of what we just did. So we were given the polynomial and we found the zeros. Here we are going backwards. We have the zeros and we want to find a polynomial. And then we have a condition given here as well. What is the condition? That the constant is -30. Now, condition can be given to any, for any term. It doesn't have to always to be the constant term. So what do we do here? We start by looking at what is the degree of the polynomial and how many zeros are given. So remember that combining the real and the non-real, or you can say real and complex zeros, the total number of zeros must be equal to the degree of the polynomial. So here the question is saying find a polynomial of degree 3 with zeros 2 plus I and 3. Now these are only two zeros, so we should have three of them. Now if we are given two real zeros, so if the question says these are the only two zeros for a polynomial and find now a polynomial of degree 3, then it means one of the zero must be repeating. But when you have complex zeros, then remember they always appear in conjugate pairs. So if 2 plus I is a 0, then 2 minus I must be a 0. And that is where we start. That is our third 0, 2 minus I. So that is what I wrote here. So we will start by saying that P of x equals A times x minus 3 times x minus the 2 plus I 0, then x minus 2 minus I. And then I distribute these inside brackets and I get this. So now notice that this is so we have three factors which we have to multiply. So always when you have a pair of conjugates in the product, then always multiply the two conjugate pair factors first. That will simplify things for you for the next step. So that's what I did here. I multiplied all these two and got ultimately, see, I terms are cancelled. Now the last one here is I square. I square is negative 1, and so I replace the by negative 1, so negative 1 makes it positive 1 over there. Another way to multiply it, which is I think is a little bit simpler or easier, if you can see the presence of a difference of squares. Sorry, yeah, difference of squares formula you can apply. So here we have x minus 2 minus I and then x minus 2 plus I. So this can be a times x minus 3 times, so it can be x minus 2 whole square minus I square. It is a x minus 3 times x square minus 4x plus 4, and then this is plus 1. So you see this is a little bit less, a little bit shorter than what we have down here, but it's your choice. So eventually expand everything and we end up getting an expression like this. So now our job is to find the A, and we use the given condition. So we have that the constant term is negative 30, but what is our constant term? Is negative 15a. So take negative 15a, set it equal to 30, negative 30, and we get a is equal to 2. Now go back, plug in a 2 for a, and that is your polynomial. Okay, we'll see next video, in next problems in the next video.